Hello everyone. In this class we will see the basic concepts of trigonometry. If one ratio is given trigonometric, then how to find out the other ratios and how to find the third side by using Pythagoras theorem. So whenever you come across the right angle triangle, remember the important things. The right angle whatever is there, okay? So in this triangle ABC, this B is a right angle triangle, B is a right angle. So the opposite side of this right angle, that is called hypotenuse. Okay, so here the angle B is 90 degree here. So the opposite side of this 90 degree, whatever side is there, here it is AC, so that is called hypotenuse. Okay, that is the longest side of the triangle ABC, hypotenuse. Now the remaining two sides are opposite and adjacent. So opposite side and adjacent side are depend on the angle. Suppose I am taking my angle, let's say theta here. So the opposite side of the theta, which is nothing but this AB, so that is called opposite side. And the remaining side, whichever is left, BC, that is called adjacent side. Okay. But suppose if I take my theta here, instead of angle A, instead of angle C, angle A, if theta is here, then opposite side of theta is nothing but now BC. And adjacent side in that case is AB, if your theta is here. Okay. For example, let's say one more triangle PQR. Q is 90 degree. Okay, so our theta is here, let's say. So in this case, your opposite side is QR, adjacent side is PR, and hypotenuse is fixed, opposite of 90 degree. Okay, so based on that we have the formulas. Sin theta is nothing but opposite upon hypotenuse, and the reciprocal of sine, which is cosec, that is hypotenuse upon opposite. Then second is cos theta. So cos theta is adjacent upon hypotenuse, and the reciprocal of cos theta, which is called sec theta, that is hypotenuse upon adjacent. Then tan theta, that is opposite upon adjacent. So the reciprocal of tan theta, which is cot theta, that is adjacent upon opposite. So for any right angle triangle, we can apply the Pythagoras theorem, which is given by the square of the hypotenuse is equal to square of the opposite plus square of the adjacent. Okay, so this is the Pythagoras theorem. Now let's start with the example. So let's start with the simple basic example. If sin theta is equal to 3 upon 5, then find the remaining trigonometric ratio. So now here angle sin theta is given 3 by 5. Triangle is not given. Okay, so let's consider one triangle, right angle triangle only. In that only we can apply this ratios rule. So let's say the name of the triangle is ABC. So given that sin theta is equal to 3 upon 5. So let's consider our theta is here. You can consider it angle A also. Okay. So if I consider, let's say theta is here at C angle. So sin theta is given 3 by 5. Okay. So sin means what? Sin means opposite upon hypotenuse. So this 3 is nothing but opposite, and hypotenuse is nothing but AC is here, which is 5. Okay. So we have to find out the remaining ratios. So let's consider, so sin theta is given to be 3 by 5. So this 3 is nothing but here our AB side, the opposite of theta, and hypotenuse, which is opposite of 90 degree, which is 5. Okay. So here 3 is our AB side divided by 5 is our AC side. So let us consider AB is equal to some 3 times K. Okay, because this is a ratio 3 by 5, not actual number. So AB is equal to, let's say, 3K, and AC is equal to, let's say, 5K. So if we apply the Pythagoras theorem in this triangle, so in this triangle ABC, so what is the Pythagoras theorem? The Pythagoras theorem we have square of the hypotenuse is equal to square of the opposite plus square of the adjacent. So in this triangle hypotenuse is AC, so AC square is equal to opposite side, or we can say it is a height, which is AB, so AB square plus adjacent, so adjacent is here BC, so BC square. So AC, which is 5K, so we'll write down here 5K the whole square is equal to AB. So AB side is nothing but 3k. So 3k the whole square plus BC side, that we have to find out. Okay. So if we take the square, so 5k square, that is nothing but 25k square is equal to 3k the whole square, which is 3 square is 9, k square is k square plus BC square. So if we take this 9k square to the left hand side, 25k square minus 9k square is equal to BC square. So 25k square minus 9 square k square, which is 16k square, is equal to BC square. So if we take the square root on both the side, we will get root of 16k square is equal to square root of BC square, which is BC. So square root of 14, which is 4, and square root of k square, which is k. Okay. Before that plus or minus sign will come, but side cannot be negative, so we will consider only positive length. So our BC value is nothing but 4k. Okay. This is 3k, this is 5k. So we have to find out the remaining trigonometric ratios. So now we will apply the formulas. Okay. So sine is already given 3 by 5. So from the reciprocal cosec theta is nothing but the reciprocal of sine. So sine is 3 by 5. So cosec theta is nothing but 5 by 3. Okay. Now next let's say cos theta. So what is cos theta? Cos theta is adjacent upon hypotenuse. So our theta is here. So the adjacent of theta, which is BC side. Okay. So BC upon hypotenuse. So hypotenuse is AC. So BC is 4k upon AC is 5k. So this k and k will get cancelled. Cos theta is 4 by 5. So if cos theta is 4 by 5, then the sec theta, that is the reciprocal of cos, which is 5 by 4. Similarly, we can find out tan theta. So tan theta is nothing but opposite upon adjacent of the theta. So our theta is here. So opposite side of the theta, which is nothing but 3k. Okay, you can write down the name of the side first, which is AB upon adjacent side of the theta, which is BC. So AB is our 3k and BC is 4k. So the ratio is 3 by 4. So if tan theta is 3 by 4, then cot theta will be what? 4 by 3, reciprocal, right? Look at the next example. Okay, so the question is here, in triangle PQR, angle Q is equal to 90 degree. If cos P is equal to 5 by 12, then find the length of PR, sin R value and tan P value. So let's draw the triangle first. In this triangle name is given PQR. So if you draw the right angle triangle PQR, right angle is given at Q. So Q is here, let's say P is here and R is here. So PQR, this is a right angle triangle. So what is given? Cos P is equal to 5 by 12. So P angle is here. We have given cos P, which is equal to 5 upon 12. So cos is nothing but adjacent upon hypotenuse. So this phi is corresponding to adjacent side. So P angle is here. So hypotenuse is fixed opposite of Q. So hypotenuse is given 12. So this side is 12. And the opposite side of P, which is QR. But we want adjacent. So the remaining side PQ is our adjacent. So this phi is our adjacent value. Okay. So we have to find out the length of QR here. Okay. In the question it is here, find the length of QR. Okay, so we'll apply the Pythagoras theorem first. Let us consider this PQ is equal to 5k, PR is equal to 12k. So the remaining value QR we have to find out. So we'll apply the Pythagoras theorem. So Pythagoras theorem is what? Square of the hypotenuse is equal to square of the opposite plus square of the adjacent. So hypotenuse is here PR. So PR square is equal to PQ square plus QR square. So PR is given 12. So 12k the whole square is equal to PQ is 5k. So 5k the whole square plus QR we have to find out. So QR square as it is 12k the whole square, which is nothing but 144, and k square, which is k square. 5k the whole square, which is 25k square, plus qr square as it is. So if we take this 25k square to the left hand side, we will get 144k square minus 25k square is equal to qr square. So 144k square minus 25k square will get 119k square is equal to qr square. So if we take square root on both the side, we will get square root of 119k square is equal to qr. Okay, square root of qr square, which is qr. So the value of qr is nothing but square root of 119 and square root of k square, which is k. So the value of qr is nothing but root 119k. Okay, so first question is done. Now the second question is find out sine r. So sine r we have to find out. So angle is here r, so we have to look at angle r here. Okay, so if I draw triangle one more time, P, Q and R. So from R we have to see now. So what is the formula for sine? Sine is opposite upon hypotenuse. But opposite from which angle? R angle. So what is the opposite side of angle R? PQ. So we have to write down PQ divided by hypotenuse, which is PR. Okay. So PQ is nothing but here 5k. So we'll write down 5k divided by PR. The value of PR is 12k. So k and k will get cancelled. So our answer is 5 by 12. And the second question is, third question, that we have to find out tan P. So tan P. So angle is here P. So we have to look at from angle P. So tan is nothing but opposite upon adjacent. So the opposite side of angle P, okay, you can see that from here, P angle is here. So opposite side of P, which is QR. So QR divided by adjacent of side P. So adjacent side of P is PQ. So QR upon PQ. So what is QR value? Root of 119k divided by PQ is nothing but 5k. So this k and k will get cancelled. Our answer is square root of 119 divided by 5. Okay. Look at one more example. Let's solve the next question. In triangle MTR, angle T is equal to 90. Sine R is given 24 by 25. Then find the value of cot M, sec R and cos M. So let's draw the triangle first. Triangle name is MTR. Angle T is 90 degree. So let's say M is here and R is here. So what is given? Sine R. So angle is here R. So from the angle R, sine R, which is given to be 24 by 25. So we know that sine is nothing but opposite upon hypotenuse. So in this triangle, hypotenuse is MR. So let's consider hypotenuse is 25k and opposite is 24. So opposite of which angle? R. So opposite side of angle R, which is MT. So let us consider that is 24k. So which is unknown side? TR. So we have to calculate TR. So by using Pythagoras theorem, we can write down MR square. Okay, hypotenuse is here MR. So MR square is equal to MT square plus TR square. So MR is nothing but 25. So 25k the whole square is equal to MT, which is 24. So 24k the whole square is equal to, plus TR we have to find out. So TR square as it is. So 25 square k square, which is 625, k square, which is k square. Then 24k square, which is square of 24, which is 576 k square plus TR square. So if we take this 576 k square this side, we'll get 625 k square minus 576 k square is equal to TR square. So if we subtract this, 625 minus 576, we'll get 49k square is equal to tr square. So if we take the square root on both the side, square root of 49k square is equal to square root of tr square, which is tr. So from here we'll get tr is equal to 49 times k. So we got the value of tr, which is 49k. Now let's find out the value of remaining ratios. So we have to find out cot m. So cot m. So the formula for cot is nothing but adjacent upon opposite. But from which angle? From the angle m. So our angle m is here. So for angle m, the opposite side is tr. Okay. So in the denominator tr will come, and in the numerator adjacent. So what is the adjacent side of angle m? Adjacent side is mt. So mt upon tr. So mt is nothing but 24k divided by tr. tr is nothing but 49k. So k will get cancelled. So answer is 24 by 49. Sorry, root of 49 is here 7. So tr is nothing but 7k. Okay, not 49k. tr is 7k. So 24 by 7k. So answer is 24 by 7. Similarly, we can find out sec r. So sec r is equal to, sec is nothing but reciprocal of cos. Cos is adjacent upon hypotenuse. So sec is hypotenuse upon adjacent. So hypotenuse is what here? mr, that is fixed, upon adjacent. So adjacent of which angle? R angle. So for R angle, the adjacent side is nothing but tr. So mr upon tr. So mr is 25k divided by tr. tr is nothing but 7k. So k and k will get cancelled. So answer is 25 by 7. Similarly, we have to find out cos m. Okay. So we cannot find out directly the reciprocal of sec, because here the angle is r, here the angle is m. Okay, so we have to look at the value of cos from the angle m. So cos is nothing but adjacent upon hypotenuse, but adjacent of which angle? M angle. So for angle m, the adjacent side is mt. So mt upon hypotenuse, which is mr. So mt value is 24k, mr value is 25k. So k will get cancelled. So answer is 24 by 25. Okay. Look at one more example. So the question is, in triangle xyz, angle y is equal to 90 degree, tan z is equal to 8 by 15, then find the value of sin x, cos z and tan x. So if we draw the triangle with 90 degree at y angle, so let's say this is x and here it is y. So what is given? Tan z. Tan z is given to be 8 by 15. So we know that tan is nothing but opposite upon adjacent. From which angle? Z. Okay, so let's say our z angle is here. So from the xyz, z angle is here. So opposite side of the angle z, that is nothing but xy. So let's say that is 8k. Okay, opposite side is 8, so 8k. So xy is equal to, let's say, 8k, and adjacent side of z. So adjacent side of angle z, which is nothing but yz, that we will consider as, let's say, 15k. So yz is equal to 15k. So which side is unknown? xz. So we will apply the Pythagoras theorem. So in triangle xyz, by using Pythagoras theorem, square of the hypotenuse, so hypotenuse is xz, so xz square is equal to xy square plus yz square. So xz, that we don't know, we have to find out. So xz square as it is equal to xy, which is 8k, so 8k the whole square, plus yz, which is 15k, so 15k the whole square. Okay, so 8 square, which is 64, into k square, plus 15 square, which is 225 into k square. So if we add up this 64 plus 225, we'll get 289 k square, and this side xz square as it is. So if we take the square root on both the side, so xz is equal to square root of 289 into k square. So root of 289, which is 17, root of k square, which is k. So the value of xz, we are getting 17k. Okay, so let's find out the first things, that is sine x. Sine x. So sine is nothing but opposite upon hypotenuse. Okay, and angle is x. So x angle is here in the triangle. So opposite side of angle x, which is nothing but yz. So yz upon hypotenuse, which is xz. So yz is 15k upon xz is 17k. So k and k will get cancelled, so answer is 15 by 17. Similarly, we can find out the remaining part, that is cos z. So cos z is nothing but adjacent upon hypotenuse, but from the angle z. So our z angle is here. Okay, our z angle is here. So adjacent side of the angle z, which is yz, divided by hypotenuse, which is xz. So yz is nothing but 15k upon xz, which is 17k hypotenuse. So k and k will get cancelled, so answer is again 15 by 17. And the third thing, which is tan x. So tan x is equal to, so tan is nothing but, okay, our tan z is already given, but that is from the angle z. We have to find out tan from angle x, the value of tan x. So tan x is nothing but opposite upon adjacent, but from the angle x. So if you look at from the angle x, the opposite side of angle x, which is yz, divided by adjacent side of x, that is nothing but xy. So yz upon xy, yz is 15k upon xy is 8k. So if we cancel out k, we'll get 15 by 8. Okay. So this is the practice homework question for you. Triangle ABC, angle B is equal to 90. Cosec A is given 41 by 40. So you have to find out sec, cot and tan A. Okay. So I'll give you the hint. You have to draw the triangle ABC. Angle B is 90 degree. Okay. ABC. So it is given that cosec. So cosec is nothing but hypotenuse upon opposite. But from which angle? From angle A. So angle A is here. Okay. Hypotenuse, which is 41. So this will be 41k. And opposite of angle A. So opposite of angle A, which is BC side, that is given to be 40k. So you have to find out the AB side first of all by using Pythagoras theorem. Then you can find out the value of sec A, cot C and tan A. So find out by above method and comment your answer in the comment section. Thank you.